So hi everybody. So today we're going to go ahead and go over 1.5, which is geometric sequences. It's very similar to arithmetic sequences, just one slight little difference. Okay, so geometric sequence is any sequence with a common ratio r. Okay, so when it was arithmetic, it was d for common difference. This is common ratio, so it's r, and that is what becomes between terms. We find this r by taking any term of the sequence, and dividing it by the prior term. That is, given this sequence, then r is equal to ai all over a of I minus 1. Remember, a of I is just an arbitrary value in that sequence. And then I minus 1 is the thing that comes just prior to it. Okay? So example 1.5.1, does this sequence represent a geometric sequence? If so, what is its common ratio? So if it is, then it should have the same common ratio all the way through. So let's just figure out what the common ratio is. I'm going to go 6 divided by the prior one, which gives me 2. Now, if this is geometric, it should be equal to the common ratio anywhere else. So I'm going to go ahead and say 15, pick that value, and divide it by 12. And you can see 3 goes into both of them, so you have 5 fourths. So 2 is not equal to 5 fourths. So no, this is not a geometric sequence. Okay, the common ratios have to be the same. Okay, does this sequence represent geometric sequence? Hopefully you can see that it does. You're just multiplying by 2 every time along the way. So r is equal to 2. If you don't see that, once again, you can pick any arbitrary value in that sequence, say 8, divided by the number that comes just prior to it, and you get 2. So yes, this is. Okay, now this one's tricky because it goes negative, positive, but that's okay because all that means is you're multiplying by a negative every time along the way. So does this sequence represent a geometric sequence? So going from there to there, it looks like I'm dividing by negative 3, divide by negative 3, divide by negative 3. So yes, this is with r is equal to negative 3. Once again, and I actually said that wrong. I said I'm dividing by negative 3. But that doesn't make the common ratio negative 3. Let's take a look. Once again, you can find it by taking any term in the sequence. So I'm going to take 3 and divide it by the prior one, which is negative 9. So it's negative 1/3. So the definition of geometric is that you're multiplying by that value every time along the way. If I was multiplying by negative 3, these terms, at least the absolute values would get bigger and bigger and bigger, but they're getting smaller. The common ratio is actually negative 1/3. Okay. Does this sequence represent a geometric sequence? If so, what's the common ratio? You can see I'm multiplying by negative 1/2 every time along the way. So yes, this is with r is equal to negative 1/2. Once again, if you don't see that, let's go off to the side and let's figure out what it is. So I'm going to pick negative 1/4 and I'm going to divide it by 1/2. Okay, to divide fractions, you flip and multiply. So negative 1/4 times 2 over 1. Those will cancel, so I have negative 1/2. Okay, so finding a recursive rule for finding the n plus 1 term. So recursive rule, remember, it's determined by the one that comes just prior to it. So you take any term in that sequence, multiply by r, and you'll get to the next one. Okay, so find the recursive formula for the sequence this. As you can see here, the common ratio is 2. So the recursive formula is simply a of n plus 1 is equal to a of n times 2. Okay, that's all you have to do. Just like with arithmetic, all you needed to place in was d for arithmetic. All we're doing is replacing an r here. Okay, right here, you can see I'm dividing by 5 every time along the way, or I'm multiplying by 1/5. So that means my recursive formula is a of n plus 1 is equal to a of n times 1/5. Okay, and that is the formula. Okay, next page. Okay, definition 1.5.3, find explicit rule for finding the nth term of this geometric sequence. So this is the formula that's given for finding the nth term of a geometric sequence, okay? A of 1 is still the first term. R is still the common ratio. And then n is just the number in that sequence. Okay, or the numberth term in that sequence. Okay, so that's all it is. Okay, so find an explicit formula for the sequence, -1/2, 1, -4, 16, -64, and use it to find the nth term. There's going to get some big numbers here pretty soon, so I'm going to bring up my graphing calculator, which you can see I just did. I'm just going to shrink it down real quick. Okay, and let's try and put this in the backdrop. Okay, hopefully that works. Okay, so we're going -1/4, 1, -4, or 16, -64. Hopefully you can see r is going to be equal to -4. Once again, if you don't see that, take any two terms in that sequence and just simply divide them. I'm going to take -4 divided by 1. So that gives me -4. Okay, so the explicit formula is going to be a of n is equal to the first term. First term is -1/4 times the common ratio, which is -4, to the n minus 1 power. Okay, I want to find the 8th term in this sequence. So I'm going to try and find a of 8. So that's equal to -1/4. I'm going to teach you some tricks here instead of just multiplying it straightforward. Something will kind of help us out a little bit. Not too much, but a little bit. Okay, and then here you're going to have -4 to the 8 minus 1 power. Okay, so this is going to be -1/4 times -4 to the 7th power. Now, if you take a negative and you multiply it to an odd power, it's going to end up being odd back, right? If you have an even amount of negative numbers, sorry, I said that wrong. If you have a negative times a negative, it's going to turn into a positive. Now, the thing is I first have to take it to the 7th power. When I take it to the 7th power, a negative raised to the 7th power is still going to be negative. In other words, this negative will pop out once I take it to the 7th power. It's going to be multiplied by this negative. So this is 4 to the power 7th all over 4 to the 1st. Because the negative times the negative is going to make a positive, and I just kept that on the top. Okay, well, that's equal to 4 to the 6th. Okay, and then here's where we'll go to our calculator. Come on, I can't drag it over there. Okay, let me get rid of this. Okay, here we go. Okay, so 4 to the 6th power is equal to 4,096. Okay, so 4,096 is my answer. Okay, let's go back and we'll move on to the next question. Okay, so find an explicit formula for the sequence 625, 125, 25, 5, and then so on. Okay, so the common ratio here is 1/5. Once again, if you don't see that, take any term in the sequence. I'm going to take 5 divided by the prior one, and that reduces to 1/5. So my explicit formula is a of n is equal to a of 1, which is 625, times the common ratio of 1/5 to the nth minus 1 power. Okay, that is the explicit formula. Now, I want to use it to find the 10th term. So a of 10 is equal to 625 times 1 over 5 to the 10 minus 1 power. Now, 625 is also a power of 5. Now, let's go up here and we'll analyze, right? 5 is 5 to the first. 25 is 5 squared. 125 is 5 cubed. So 625 is 5 to the 4th. So I'm going to come down here and I'm going to simply rewrite this as 5 to the 4th times 1 all over 5 to the 9th, which is 1 all over 5 to the 5th power. Okay, and what is 5 to the 5th power? Okay, we'll go to the calculator. 5 to the 5th power. is equal to 3,125. And that is clearly, it's 1 over it. I'm sorry, it's 1 over that. 1 all over 3,125. So that didn't make any sense. Okay, next page and last page. Okay, so the terms 140A, 4528 are the first, second, and third terms, respectively, of a geometric sequence. If A is a positive, that's key here. If A is positive, what is the value of A? So this is geometric, which means to get from one term to the next, I need to multiply by R. And to get from that term to that term, I need to multiply by R again. So in other words, if I took 140 and I multiplied by R twice, then that should be equal to 45 all over 28. Now, these are some pretty crazy numbers, but I'm going to show you how to manipulate them really nicely. Okay, so I need to solve for R, so I'm going to divide both sides by 140. And so I have R squared is equal to 45 all over 28 times 140. Now, I'm going to leave it alone like that for a moment because I think it's a little bit easier to cancel some things out. Clearly, you can see 5 goes into both of these. Okay, so I'm going to cancel 5 out of here, and I'm going to have a 9. And I'm going to cancel 5 out of here. What's that? Let's go to the side. 140 divided by 5 goes in there 28 times, so that's pretty nice. But look, I have 9 all over 28 squared. Or another way of rewriting this as I have 3 squared all over 28 squared. So I have R squared is equal to 3 squared all over 28 squared. And now when I take the square root of both sides, I have R is equal to plus or minus 3 all over 28. Once again, A is positive, so I can get rid of that negative. So R is equal to 3 over 28. Now, I still haven't answered the question because I have to figure out what's the value of A. So to get to A, I take 140 and I multiply by the common ratio of 3 all over 28. Now, does 28 go into 140? Yes, it does. You could see it all up here. It goes in there 5 times. So A turns out to be equal to 15. Okay, next question. Now this one's pretty tricky, so pay close attention. So Mike paid $1.25 stamps 3 years ago. Okay, he was offered double that amount for the stamp. Okay, so assuming the stamp's offer price doubles every 3 years, and that's the key there, every 3 years, how many dollars will he be offered 12 years or 12 more years? So let's do this. Okay, so Mike paid $1.25 for a stamp 3 years ago. So this is going to be $1.25. And then here we are right now, because this would be back 1, back 2, back 3 years ago. Okay, so he's just offered double that amount. So this is going to be $2.50. Okay, now this isn't going to be that hard because I'm only going 12 years out and I've already gone 4. Or this would be 3. So then let's go 1, 2, 3 more. So you double the amount. So it's going to be 5. And then we go 1, 2, 3 more, and it will be 10. Okay, and so we'll see how many years we're out. So 1, 2, 3, 4, 5, 6, 7, 8, 9. But we have to go 12 years from this spot. Okay, and we'll go back and do this more mathematically in a second using the formulas. I just want to kind of write it out to show you how you could do it otherwise. Okay, okay, so let's go forward 3 more years. So 1, 2, 3. So now it's going to be 20. And you go forward 3 more years. 1, 2, 3. And now it's going to be 40. Okay, so let's see. Oops, sorry. Can't see that. Okay, so from here, you're going forward 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the answer should be 40. Now, let's do it a different way. Okay, let's use the whole idea of geometric. So ignoring these, because we're just going in chunks of 3. Okay, so this would be like the first one, that's the second one, third one, fourth one, fifth one, and sixth one. Sorry. So I'm going to use the formula a of n is equal to a of 1 times the common ratio to the n minus 1 power. So this formula is going to be a of n is equal to, now it doesn't really even matter where you start at. We can start here or we can start there, as long as we come up the right n value. So I'm going to start here. So $2.50 times the common ratio. I'm doubling every time, so times 2 to the n minus 1 power. So that is the explicit formula. Now I just need to figure out what n is. So n is going to be how many chunks are you going to go forward? Well, there are 12 more years, and it gets splits into doubles every 3 years. So that means n will have to be equal to 4. And look, 1, 2, 3, 4. So this is $2.50 times 2 to the 4 minus 1 power, $2.50 times 2 cubed, which is $2.50. Sorry about that. Times 8, which turns out to be, $40. That seems wrong. No, this should be 5 because that's the first one. First, second, third. I'm sorry. So this should be 5. So this is 4. We have 16. And then the answer is 40. Okay, sorry about that. Because this was going to be I was just ignoring the 125. This is going to be the first, second, third, fourth, and fifth. Okay, so there we are. Geometric sequences. Next time we'll be dealing with geometric and arithmetic series. Slight difference. Okay, see everybody later. Take care.